Well, hello and welcome to my shop, and thank you so much for joining me today. It's April 24th, and what I have in front of me is what is this? It's a jukebox. No, not really. It's a record player hiding as a jukebox. What a wild looking thing this is. Electronic jukebox model. Looks like HY, I can't quite read that. Model number 999 is what that actually says. 999. Check out the picture here. What exactly is going on there? Yeah, that's kind of odd. 190 watts. How do you get to 190 watts with something like this? Are they full of lights? Must be full of light bulbs somewhere. Made in the USA by the Nordstom Corporation. Hey, that's similar to my last name. Bridgeport, Connecticut is where this was made. Okay, we got some funny pictures of guys on a stage here. There's a couple doing a dramatic scene or something like that. Here it says, come a little closer here, we can take a better look. Here it says, Project of Bing Crosby Research Foundation. The Bing Crosby Research Foundation? Junior Juke. It's the Junior Juke for Junior. But a jukebox really, to me, it means it has a bunch of records inside. That's not happening in here. This has, it's hard to see in the camera here, just one record inside. Ooh, pretty dusty in there. Oh, look at the record. Oh my gosh. So here's the thing. This belongs to a friend of mine. He asked me if I would take a look at it. I told him I doubt there's anything I can do with it in terms of making it operate or making it operate better or whatever. I warned him that this cartridge is probably dead in here. That's a spare needle there. And it's come with one record. Let's just take it out of there. Oh my gosh, that's a lot of dust. That size. So it's been sitting up on this side for quite a while. You're not supposed to let your records get this dusty. That's for sure. His Master's Voice, Victor, not licensed for radio broadcast, Runnin' Wild Foxtrot by Maestro Paul Laval and his Wood Windy 10. His Wood Windy 10. His Wood Windy 10, eh? How about this side? Diana's Blues by Mademoiselle Diana Shore. Can you see it says Mademoiselle? Mademoiselle Diana Shore. With Dr. Henry Levine and his Barefooted Dixieland Philharmonic. That's what it says that. It says that. Barefooted Dixieland Philharmonic. Made by the RCA Victor Company Limited, Montreal. Licensed under the Canadian patent number so-and-so. For sale at current catalog price by authority, by authorized dealers. No other person shall sell, expose. Oh my gosh, I've exposed this. Expose. Or offer this record for sale or exchange. That's weird, isn't it? I don't understand all that. Okay, anyway, there we are. Interesting record. Oh, just set it over here. Now, what about the record player? Let's look at this side. Oh, it's the same image on this side as the other side. What about up on top? Nothing special happening up there. And with the back here. So we have the Star Radio and Television, 156 Harvard Avenue, Alliston, Okay, so Alston, or Alston. Is that Alston or is that Alston? It looks like Alston. Alston. Television radio repairs. February 1st, 1951. VC and 7. I don't know what that is. Something handwritten. There's a sticker we can't read. That's probably the service warning. Don't go in here unless you're authorized or capable. Whatever. It's like 2 screws on the bottom. The back comes out. Screws up the side. Oh, excuse me. For some reason we want to take the front off. Just one knob. A one knob machine. And underneath, just see if this is, yeah, locked in. And underneath I have a couple of screws and the feet. The feet may be doing something. I don't think so though. A little saggy under there. Well, it's actually a pretty rugged beast. I mean, it's come all the way from the 1950s maybe? All the way up to here. And it looks pretty good. It's kind of neat looking. It has this interesting thing here, which you would think you would light from the inside, but I don't feel any light bulbs. So how does this thing get up to that ridiculous wattage? Oh, there's a light bulb right here. Yeah, there's 2 light bulbs right just inside here. Okay, and I think at the back, way at the back, is the speaker. So it's going to project the sound out here. Okay, what do we do with this guy? Plug him in, turn him on? I think the next thing is take the back off. The back is going to come off real easy. And we'll see what's inside here before we turn it on. I can't remember if he told me it worked or not. It's not very likely. It's only 78, I'm pretty sure. 78's kind of were big right up until, you know, I'm not sure, you'd have to look in a book to be sure, but sometime in the 1940s. Then the microgroove record was introduced. You get more music on one record. You didn't need to stack them and drop them, even though the record player still did that. There we go. Okay, wow. Okay. Talking about light bulbs. There's a pretty good light bulb inside there. A little hard to get this on my camera just because of the angle of things. Power cord. So this wire is as stiff as can be. If I bend that in the slightest, it's going to crack. It's probably cracked somewhere up in here. What a teeny tiny little amplifier. It's a 2-tube amplifier with a gripping light bulb. The light bulb is why this thing uses so much power. Let's see what it is here. It's a 40. Okay, it's not much. 40. Well, since I have safe ways of turning these things on, why don't we turn it on? I'm going to turn on with a restriction on the supply voltage or current, however you want to look at it. See what it does. So I'll be feeding the power to this through a couple light bulbs. That's commonly called a dim bulb system. And that's in case there's a short circuit in here. All that's going to happen is these lights are going to come on bright back here. Okay, this is turned off, so we're going to check and see if off is off. Is off off? Off is definitely off. Okay, we're just going to turn down the voltage a little bit. Now when the dim bulb is in, the voltage reaching the item under test is reduced. But with no load, 114 volts. Okay, shall we see what it does? What's it going to do? Maybe it's going to hum like crazy. The lights came on. See, my dim bulb lights have come on too. The big light has not come on. This is barely turning here. Now it's a 78, so it should be ripping right along. That's definitely not ripping right along. So, oh, what happened there? What's happening? I don't particularly like it. So it just turned it off just as the speaker was coming up. Yeah, what was happening there? That was a completely unexpected thing going on and off like that. That's a hard one to explain. Let's see. The motor seemed to die. The dim bulbs seemed to get light. Oh boy. These bulbs seem to go dull. Seemed to me something was shorting out inside. Periodic short out. Maybe a tube heater in here. Should we run it again? Is there a flasher on that light? Let's try it again. Here we go. Keep your eye on the bulbs there. This is quite bright for what's here. There it goes. This bulb doesn't go completely out. Well, okay, there's something there for me to fix, for sure. So what we'll do is we'll take the amplifier out. Oh, what about the needle? Never had a chance to check it. What's the use of doing this? What's the use of doing this if there's no cartridge action? Can I try it with it going on and off? Briefly. Briefly try it. Going on and off. Now, with it humming, it's a chance that you'll never hear the sound of the needle over the hum. Let's see. Keep going. There's nothing there. Cartridge is dead. Now, what can we do with something like this? Well, even if it doesn't play, and I'm not saying I absolutely can't make it play, it's kind of cool looking. Seeing the record player go around at the right speed would be kind of nice. Not much to it, just a board. So it looks like this has been spot welded here. That's what it looks like. Okay, we'll take out the amplifier and we'll go to work on it. To start with. Looks like I gotta take the on-off switch and volume control. Has to come off, and the lights have to come off. There they are. Oh, they're screwed in place, and So I think I see a great big resistor inside there, and it all looks burned right up to me. Looks all smoked and burned up. Okay, that's the first step. Get everything out of there. Good. Two lights are next. Boo! What was that? What was that? Okay, something went flying in my shop here. I have no idea what that would have been. Luckily, I can always look back on the video and see what it was. Okay, it's easier. This is going through a, not a nut, but a clip. Okay, let's see where we got to here. All these screws, there's four of them. One holding each of the lights, two holding this down. Use these, I don't know what to call them, clips, I guess. That's what's in there. This I found this on the bottom here, just laying here. Probably came from, probably, no. I don't know where that came from. Anyway, it came out. So here we are. This is loose now. Far out. Can we get it? Extremely stiff wire here. We will certainly get rid of this stiff part here. Look at this. Yeah. That's stiff, all right. These ones, not so bad. These ones are pretty stiff. This is going up to the motor here. Very stiff. One's going into the motor, so. Okay, so it's just writing on here 35Z5 and 50L6, and that's the two types of tubes that are in there. And inside here, I think there's a resistor. Look, this piece of metal. So that's where that is. This piece of metal is riveted on. I didn't really intend anybody to ever access the part that's under that metal. What is under there? What did they do this for? And it certainly looks like a high wattage resistor that appears to be burned up. What I can see. So we're going to have to get this off to go after that resistor, or we just replace it. Oh, some writing. A message to us. Burned out resistor. I already know that. You're not telling me anything here. Burned out resistor. Wow. That's not going to stop us. So why would the resistor be burned out? The resistor itself may change value, and that may end up causing circumstances to arise that would burn it out. That's less likely than something else going wrong, and treating this resistor to how are you supposed to get this off? That resistor's sitting there. How do you get this top part off? He asks wistfully. Tubes in here? Oh, because it comes off like this. It comes off like that. It comes off like that. There it is. Yes, sir. What do we got here that's weird? Great big capacitor. That's probably causing the hum we were listening to. Got a fair size capacitor here. That's it. 2 capacitors. 2 resistors. Look at these wires. Oh, they're cracked right under here. Oh boy, now there's a short circuit. There is a short. Look at that. That's going to short to this chassis. Goodness knows what could happen with this guy. This whole chassis is metal. Now this thing is screwed down to a piece of wood. Lots of wires running around here. Sooner or later somebody's going to round out. Hey, what's going on in here? What's with all that? That's coming off of this bottom corner. Doesn't look like it. This looks clean. Where'd all that gook come from? A predecessor to this? This is a replacement? Not very likely. Not very likely. It's a little loose. In the manufacturing, you would think they would avoid this, something like this being this loose. Maybe it is a replacement. This is the bottom of the light bulb socket. Did this light come on? I don't think this light came on, did it? Sounds okay. Maybe it came on and for some reason I didn't notice it. I don't think it. Did it come on? I don't know. Let's check it out. Not looking too good. Yeah, so this didn't come on. So, I mean, this is a big part of lighting this thing up. It lights up that whole front panel there and parts of the corners. A40. I will set that over here. I have a box of incandescent lights. I'm sure I've got something that can go in there when the time comes. Now, seems to me the approach here is pretty straightforward. Get rid of that. Get rid of that other capacitor down there. Change the power wires here, which are shot. Terrible, in fact, just terrible. I could test the tubes just to see. What about that resistor? We got to figure out the resistor deal here. Resistor deal. So why did they cover it with that piece of metal? Probably to control heat distribution. Make sure nothing can touch the resistor. And the resistor is so hot, if anything touches it, it's going to melt or burn. You don't want to run a resistor that hot. It looks like it's just been shoved, its leads are just kind of shoved through, but there's a supply lead going up. This is just a rubber grommet keeping everything from grounding here. Of course, these things have gone hard, I'm sure. Hard like a rock. So these are bound to crack. Same thing down below there. Same arrangement. Would you try to pop it out and like nip the wire here? pop it out. How are you going to pop a new one in? It has to be exactly the right dimensions. I don't even know the value of it yet, and if it's burned up, I'm not going to know the value of it because it's going to be burned off. So I had two options here. One is just physically just wrench this thing or bend it over and get it out of the way. It's not a bad option. The other one is you drill out these rivets. Somewhere I have a riveter, but goodness knows where that is. Probably the bending is a better approach. What if I'm wrong about this resistor? What if it's really okay? You can heat these things up an awful lot. They still maintain their resistance. Oh, what? What's this? What's that? This looks like a battery. Well, what is this? Eagle Electric Manufacturing. Gakor. Oh, I've never seen anything like this, but it sure looks like a battery. Where did it come from? It just suddenly appeared. it just suddenly appeared. It had to come out of the up on the top. There's nothing up here. Just go in there. That must be what it is. It must go in there. Well, what is it then? It's a fuse? There's a little small print there I can't quite read. Just the manufacturer's name, Eagle. Eagle Electric Manufacturing. Gakor. Gakor. What is that? Gakor. Well, that's an odd thing. I think it's to tone down the light, but why wouldn't you just screw like a 25 watt bulb in here if you don't like the 40? Oh, this is the flasher. This is the flasher. But wait a minute. If this is a flasher, the only way it can flash the light is the light is working. It's not much of a flasher. I mean, it's a tiny little thing. I don't know. That's a mystery item. But it sure does fit in here suspiciously. And it came from somewhere invisible. It must have fallen out of here. What? And this is definitely just an ordinary 40 watt bulb. Electric General. How about General Electric 40 watt bulb? It doesn't really make sense what the flashing was. The bulb can't be shorted out. I checked it. Bulbs don't short out. Was it trying to? It was trying. You know what it was doing? It was trying to turn on the bulb. And when it turned on the bulb, the extra 40 watts pulled down the supply on my dim lights over yonder. And that's why it got the effect it got of the flashing of all this. If I didn't have the dim bulbs in, the flasher would have just flashed this light on and off, and there would have been no effect on the machine otherwise. That's the story. Okay, got that sorted out. Gonna stop for a little coffee break and then try to decide what to do about this situation here. I don't like the options. Okay, I found the schematic on Radio Museum, in fact. Not very complicated here. Let's take a look at what we've got. So they're showing the vacuum tube here. And they're showing the crystal pickup, which I doubt is picking anything up anymore. And you can see the volume control is just right across the pickup. And the signal is fed. What? Oh, they're cool. Okay, it's a crazy clock going off again here at 9:43, which I cannot seem to stop the alarm from ringing on it. Okay, just ignoring that. What else have we got going here? If we look at the power supply, well, what they've done, they've almost certainly put the heaters in series. So here we have a 150 ohm half watt resistor, but the heaters are actually 2 and 7. What are they showing 2 hooked up to? To that? This is probably 150 ohm. This is probably the cathode resistor here. This is going back to the power. Okay, what about the other, where's the other vacuum tube? Where should be down here? A rectifier. Where? Hey, where are you? Oh, for crying out loud, it's right here. Funny how your eye just doesn't see things sometimes. Funny too how they've tipped these on an angle. Okay, so here we see the heater through this big resistor, then through this heater, and then down to this side of the power line. So you're going this side of the power line through to this side. Okay, so they're in series. No surprise there. This guy has got to knock off a lot of wattage, I think. Look, it's a 10 watt wire wound resistor is what that stands for. 210 ohms. Okay, another resistor here. Capacitor is showing 3 capacitors. I only saw 2 in there. How come there's 3 on here? Did I miss one? 0.05. Oh, this is the power supply filter capacitor here. And so is this. So we have this is one. Now there should be one other one I saw in here. Didn't I? No, I did not. I did not. Did I? I can't remember now. Looks like there's just the 2 filter capacitors, 30 and 40. You can probably throw a couple 50s in there. Now we look at the lights. So these are 115 volt light bulbs in here. And there it is, flasher, bi-metal strip, flasher, 40 watt yellow bulb. Of course the one that's in there is just a white bulb, but it's a 40 watter. Okay, pretty straightforward here. Now, what do we do about this crystal pickup? We gotta have some kind of a plan for it. How do we know for sure it's dead? We'd look for a voltage back here, or from here to here, right across the potentiometer. Sure. We'll look for a voltage across this potentiometer and see if we can find out if this pickup works before we do too much more. Good. Okay, so I've hooked a couple clip leads across the volume control, which is essentially across the cartridge up here, and then I've hooked up those leads to this voltmeter, which I'm going to set to AC. Most sensitive setting on AC. A cartridge like that should kick up maybe even a volt. This is a 1.5 volt scale, so we should see something if there's anything. Something if there's anything. I'm just going to move the out of the way here. Okay, watching the meter. See it moving? Gotta really flick on this meter, on the. So there's something left in the cartridge. Is that enough? Well, I don't know. It's something. We have to actually operate the record player to find out. Good. That's good. That means this thing has the potential to play records. So, now what about the mechanical problem of this being so, I mean, how is this even done up here? Let's investigate that a little bit. Probably a rim drive. So we're going to pop this off here to do some lubrication here anyway. It's a bit of a E-clamp here. off. Now, can I just lift this off? 1, 2, 3. 1, 2, 3, 4. 2, 3, 4, 5. Okay. So I'm imagining this just pops up off this. Let's just try a little technique here. It's a little brutal. Yeah, nice sharp. Yeah, maybe this one will do it. Don't think that did a thing. How are we going to get this off? So this is a common problem in record players, is getting this off. Let's just try the series now. Cover your ears because I'm not adjusting the microphone volume just above here. Voila. $3X183. There we see the wheel. This is still rubbery. Isn't that something? Oh, it's good. It's got. So what I'm doing is I'm just dragging my nail on the rubber here a little bit to see if it slides over, and it doesn't. It's actually very good. And the motor's spinning free. What wasn't turning free? Because this ran so slowly. I don't know. This isn't the best lubrication here. It's nothing more than just a. It's a very, very, very simple thing. This it's just an on and off switch, so this stays in contact the whole time. There's the spring effect here. And I don't imagine this is producing bad traction. I think it's probably producing good traction. Get a little slippery in here. Bit of rust. That should slow it down, wouldn't it? Why go so slowly, Mr. Motor? We don't know yet. Could just be simple lubrication. Okay, what's next on the hit parade here? This is going along pretty good, actually. Why don't we fix up the amplifier? We got to solve the problem with this resistor deal. The resistor deal. Now, this is sitting way in the open, so like if I bend this back, like if I do this, oh, you know what? It's going to bend down here. Put a tool on it. You could drill these out and just put nuts back in. Just put a nut and, yeah, that would be a good idea. That would be a better idea, I think. Drill these guys out. Okay, got a plan. Time to stop and think a bit, because it just involves a drill. And maybe drink some coffee. No need to drill it out. Just pull it out. Hey, look at this. Hey, look at that. I just flip it up like that. You can see the resistor here. Looks like it's damaged right in this area. Hard to say. Hey, we should really measure the value of that before I go ahead and change it. Maybe I am wrong about that. Just let me, yeah, I think we should measure that. Okay, so this resistor is in the heater string. If I pull out any one tube, I'm going to pull both these out anyway. that'll open circuit that circuit, so there won't be any interfering current paths. I got a couple clip leads I clipped onto the resistor already. Making ohm readings with clip leads, not the best idea. So it's supposed to be a 210 ohm resistor. Now look at that, it's right there. So, you know, dumb of me, I drilled this out for no good reason. Wire wound resistors are rugged, that's my experience with it. So I don't think this is a problem at all. Could it be going wild when it heats up? I don't think so. It's going to go up a little bit, I suppose, when it heats up. Okay, that was a bit of an exercise in drilling that wasn't not necessary. That's okay though, I'll just put the cover back down. We'll concentrate now on these two capacitors. This is a 40, red is 40, blue is 30, so this is a 40-30, and I think that matches the schematic. Let me just take a peek on my own here. A 40 and a 30. So you know what? There's a good chance this is original. Well, we're going to get rid of it. We're going to stick in two 50s in here. Okay, I've installed the two new capacitors. I can now remove the old one. Here. This will get rid of the hum that was apparent here. Oh, there's a mistake. I made a mistake. Put this on the wrong terminal. Oh boy, oh boy, oh boy. That's not good. Just a trick of the light. Okay, I'll solder that back into the right spot. Oh, good thing I found that. Okay, power cord next. Now, this is the two power wires coming in, come through the hole. One goes over to this terminal. I'm just going to cut it here and leave a tail. Oh, just shatter. I'm going to shatter it here. There we go. Okay, so this can come out. The other wire actually comes in, heads out through another hole, and goes all the way up to the on-off switch, which is quite a long ways. So, what to do about this one? Because it's going to, what I was going to do is I was just going to shorten up the power cord. That's going to shorten it up quite a bit. It's not particularly long to begin with. Looks like it's an okay shape, not polarized. Maybe this is the time to put a polarized plug on here. I think this is probably the right thing to do with this one. Sometimes I put a polarized plug on these guys. Other times they don't bother. Not consistent. So let's get rid of this cord, and I will find a nice long polarized plug we can put on it here, and we'll make sure the hot plug goes to the switch. But it doesn't make these things super safe at that point. That's not what happens here. In fact, let's look at the chassis connections here. Are there any? Yeah, right here. Soldered right down to the chassis. So this has the potential to be alive. Wow. There we go. So I have a new power cord, a polarized plug on the end. I fed the hot wire up to the switch. Brought a wire down here, just made a connection to the power cord under here. Very good. So we've got new power supply capacitor, new power cord. We need to replace this, or do we really? This capacitor that's buried under here. I'm going to avoid it for now. You know why? I was going to say it looks like it might be a special capacitor, but I think it's just jammed up against here. Yeah, I thought it was maybe a shielded capacitor, but it doesn't look like it. Let's leave it for now. Okay, we're leaving the resistor up here for now. Is it measured good? Try to stick the rivet back in. Okay, where are we at now? Now we're at, strain relieved it here a little too much. Okay, time to test both of these tubes. Okay. $50L6, just what the doctor ordered, and this is going to be a, what is this? 35Z5, I believe it was. It looks like the name is worn off of it. But it sure looks like a 35Z5. I don't think there's any reason to doubt it. Not at this point. Yeah, it doesn't say anywhere what it is. Very good. Let's give those tubes a test. Okay, ready to test the rectifier here. Let's just double check things. 35Z5, so 35 volts. And the numbers are 07003, 07003, 0160, 610. Got that backwards for a moment. 23 and E. Okay, she's ready. Let's pop it in. Okay, first thing we will do is check for shorts. There we go. Any shorts in this tube? And the answer is no. The needle would go up if there was a short in there, even a partial short. Okay, we're ready to test. Push the rectifier and diodes, and all it's got to do is come above my finger here where it says rectifier's okay. Rectifier's okay. Okay, that's the first tube done. Okay, ready on the next tube. You know, this is the entire amplifier in there. Just one tube. Takes the cartridge signal and makes it strong enough to drive a speaker. Try that with a transistor. Okay, 47 is the voltage setting for the filament, 8 on the signal level. The bias is 18H. The numbers are 07345, 07345. 0610, 0610. 43. And the plate is C. We're good to go. Okay. Let's see how this does. Now I'm going to guess that this jukebox has not been used very much, has not played many records in its life. Okay, let's look for shorts. None. Now we're going to measure the mutual conductance or transconductance. This should come up to 1,000 on the meter here. It should come up this high. Well, it should come up higher than that. That's the reject point I'm pointing at. Here we go. She's over. So nothing wrong here. Good. Two good tubes. We turn this to a safer level. Not a good idea on a tube tester to leave the filament voltage setting way up high. Very good. So all we got to do now, what do we got to do now? Now we've got to do the lubricate, get the motor speed going properly. We must get the motor speed going properly. Maybe I'm going to stick this flasher back in here. Oh, is there an up and a down on this? I would guess they put the words on the top. Probably not. Probably all that's in here is probably a little heating element. Probably a bimetal strip, in fact. And it's bimetals. You know, they have two metals fused together, like my fingers. Like just these two fingers. Forget the other ones. I can't get rid of them, so they just ignore them. So these fingers, one is one metal, one is another. When you heat them up, one metal expands more than the other, and it causes it, I can't curve my finger very well, but it causes it to bend. Then you just have a switch arranged on the bend. So with the lamp one way, you know how it works, I don't have to explain it. Drop that in there. Never seen a flasher like that before. The bulb in. Now, we need to do some, first we need a little more light in the shop here. How about that? Lubrication, right. It's just, there isn't very much to this guy to lubricate. Why was it going slow? So we'll do a little lubrication under here. There was a lot of torque driving this, so you know you'd need a huge drag here to slow this down. The possibility is this was not. How's that work? Wasn't there a spring in here before? There should be a spring pulling the wheel, hard to see here, against the capstan on the motor, or the motor drive shaft, and the record rim, which is going to be traveling right through here. So there's usually a spring forcing it this way, kind of between these two contact points. This looks like the spring here. Some kind of spring arrangement. Not so good. So you don't have the platter on here. You kind of have to guess where this wheel ends up. I think part of the problem here is the spring cannot apply the force. It needs to pick something sticky in here. And really, it's very hard to see what's going on. So we have plates of metal dragging on each top of each other. Where's the spring? The spring must be underneath here. Oh. The motor has a cooling fan on it. I don't see any spring under there. How is this held on? It almost looks like a rivet. I think the rubber wheel is still good enough. So you just hit this with some lubrication, make it snap better into place. I think that's the case. Even that helped. It can move. Look at this. It can move like this. Why would they allow it to do that? So a lot of record players, when you turn them off, and the actual mechanical off switch pulls the idler wheel, this is really called the intermediate wheel, away from everything. so it doesn't lay in contact. And I just don't see how that mechanism can exist in here. There's no speed control. There's nothing. Unless some clever engineer figured some way it would do it on its own. How would it do it on its own? Well, the only thing I can see is to throw a little grease under here and here and here, just a little bit to get things sliding a little better. And they have a little bit of rust on them somewhere that's kind of stopping it from sliding. Okay, a little bit of grease. So I'm using synthetic grease. And we'll just be kind of general with it here. Don't get it on the wheel. Not on the wheel. I can't use my finger on this because I'm going to get it on the wheel here. I need a stick to apply it. Okay. Oh, touch the wheel. Don't touch the wheel. Don't touch the wheel, he says. I got grease on my fingers. Hurt anything? Okay, is that a little better now? I guess so. Is that going to make the thing spin at the right speed? I doubt it. It might have motor problems. It might be causing it to turn at the wrong speed. We can just turn it on like this, and we can watch this and sort of judge whether it's going fast enough. Should be going thump, 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 thump. Should be going around pretty quick. Thump, 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 thump. At 33, at 78, this thing should be just ripping, in fact. So are we ready to turn it on? Are we ready to turn this guy back on? Can we do it just like this? I'm just kind of laying around here. Light bulb sockets laying around. Looks like I didn't have to take those light bulb sockets out. Looks like the wires were long enough. This light's going to come on and do the flashy thing. If it does, I really can't. You know what? We're going to stop the light from coming on because I'm going to want to keep the dim lights in the circuit, and with the flashing thing, it causes the voltage to go too crazy. Plus, the dim bulb's going to drop some volts off, and they won't be available for the motor. So perhaps that's why it was going slow in the first place. Okay, and this has come off its grip here. Something wrong there. There it is. Okay, so we will power it up. Let us power it up here. Got a few too many things on the bench. Step back a little bit. Okay. Plug it in. This will be the first time since I did some wiring stuff, so there's a chance I boobed it up. There's always that chance. This is where the dim bulbs will save me. Is this safe to just be laying here like this? I think so. This is cardboard. This is not, this is wood or some kind of press board or something. Here we go. Okay. There it goes. Let's give it the full voltage here. Now it's really cooking. That's what we wanted to see. Good thing it's not noisy. Wow. don't think there's any way to quiet that down. When we put the platter on, then the platter is going to amplify that. Oh. Oh, it's amplifying. Of course, it's amplifying. Okay, let's scrape the... Nah, I don't know where the volume is. Let's scrape the needle here. I don't hear anything. But I don't think I want to touch that volume control with it laying there like that. Wow, this is just roaring along here. Okay, that's pretty good. A little more cleanup. Put the platter back on. Stick a record on, and let the needle do its best to produce some sound here. Look at this thing just roaring. I feel like I'm in a factory somewhere. Okay, power off. Boom. Yeah, this just stays right in contact. Doesn't go anywhere. Okay, very good so far. Maybe this is actually going to work. Okay, well, in fact, a couple hours have gone by here. I've been out to Costco and other things. I'm back here and cleaning this up, getting it ready to operate it. And I thought, why not weigh the weight of this this thing? Yeah, let's do that. If you play records and you've never ever picked one of these up, and you're used to picking up a magnetic cartridge or even a ceramic cartridge, that'd be 2, 3, 5 grams. You pick up one of these, it's shocking. That's what I would say. Shocking. Let's see what we get here. You may not be able to read the result, but I will. $70 grams. 70 grams. Wow. That's an awful lot. You know, I have a hard time imagining a 70-gram weight with a needle on the end being dragged through some groovy plastic and not just, lathing it to death. I guess there must be some lathing going on. Okay, I think what I need to do now is put the platter back on. We should do a little lubrication in there on this. Just underneath there. So good, I can't really see how much oil I'm putting on, but this is a very tiny amount here. You know what, I think there's another approach to this. This is locked in. Really turn this over here. And I'm oiling it, at the bottom instead of the top. Oop, oop, oop. That's way too much oil. Got carried away there. So, it's hard to make the oil work uphill. Seems pretty good. Okay, oily fingers here. Okay. draggy sound. It's just running into the wheel here. Something weird about that wheel. Don't know what yet. I'm talking about the intermediate. Okay. Here we go. This is turned on with the volume low. Apply power, should start turning. Come on, man. Okay, we'll give it full power here. Oh, that's the problem. I don't have the lights in anywhere. Oh my gosh, listen to this thing. Holy smokes. How can you hear the record above it? No need to worry about the amplifier humming. Okay, I think the amplifier's on. I don't know. I don't think it's going to work. We'll put on the clean side. Dinah's Blues by Dinah, Mademoiselle Dinah Shore. I'm going to drop this on here with it spinning. It's going to go flying. Oh yeah, never going to hear it over the roar. Here we go. That's working, I think. Yeah. Can you hear over the roar?
I was happy down there. Now I'm down in the I was walking on air way down in Tennessee.
Okay. Well, I'm going to put the lights in. Wow. That came to a stop pretty quick, too. How come? I thought everything felt like it would spin nice. Well, of course, the motor's not turning, the intermediate wheel's sitting up against it, and that's up against the edge here. Well, you know what? That's really great how that worked, in fact. Really, it's almost like a round of applause. Thank you, old guy. You're still alive. I'm talking about that. So, now what did I just think? Oh yeah, we're going to put the lights in. Put in the lights. Okay, I'll put them in. We'll see what it really looks like. Well, that'll make it jukeboxy. Okay, last chance to get a little oil. You know what? I'm going to have to use WD-40 here simply because I got a long nozzle on the can. I'm just going to try to get it right up on the motor shaft. I should have done this earlier. These cans are so hard. Tension builds. These cans are hard because when you push on the knob, you re-aim the red hose. Oh my gosh! I'm pushing down the center here. What's going on? Here, drop one in. I dropped one in. Good show. Okay, we'll put this oil down here. Okay, gravity is not really helping out here. cooling fan there. Okay, seems good. Oh, I still didn't put the lights in. Okay, put the lights in. We'll thrill at this jukebox. Okay, just put a couple things away here, and we're going to play the Bing Crosby Junior Juke. Actually, it's the Bing Crosby Research Foundation. Okay. Project of Bing Crosby Research Foundation Junior Juke. And no juke was a word on its own. Ready? Here we go! It's upsetting my camera a little bit. Play that tune on the Junior Juke.
I came here from Dixon, way down in Tennessee. Life was easy behind. You're my misery.
Never forget that this is on. Walk away from it. So at the very end there, you notice the tone arm was going back and forth at the end of the record. That's a very early style of record that does that. And the idea is some of the record players were designed so that any time the tone arm moved in the wrong direction, it would pick up. That's how it knew it was time to pick up. So at the end of the record, the tone arm would go back. As soon as it went back, a pawl or a ratchet or something like that would kind of detect this, and it would indicate the end of the record. Modern records aren't done that way. Modern records, what's happening is the tone arm, which is going so slowly across the record, when it gets to the end, it accelerates towards the center, and it's that speed that causes the tone arm to pick up. Anytime the tone arm moves quickly for a long enough duration, about one revolution of the record, the modern record players will pick up. So there we are. The Bing Crosby, you've seen it. I can't believe it. I really thought this was quite a lost cause, but actually it turned out to be a pretty cool thing. So thanks a lot for watching, and gee, I wonder what I'll work on next.